Hello, everyone. I'm Shurok Khozam, a PhD student, a third-year PhD student at l'École Télécom Sud Paris. I would like to present my thesis project for attack mitigation in SDN environments using reinforcement learning, supervised by Grégory Plan, Sébastien Toxoy, and Eric Totel. We concentrate on using reinforcement learning for mitigating flooding attacks in SDN environments while preserving a network resilience and enhancing quality of service metrics for legitimate users. Our motivation for this research stems from several factors. First factor is that the expanded attack surface, especially with the proliferation of IoT devices, which made rise for several challenges and made it easier for attackers to launch their attacks. And according to Cloudflare statistical website, we noticed that DDoS attacks has doubled when we have in 2018 around 7.09 million attacks, where in 2023 this number reached 15.4 million attacks. Traditional mitigation tools, especially rule-based mitigation tools, are not able to deal with highly dynamic nowadays networks, especially when legitimate and malicious users are changing over times. And also these tools provide and produce a high latency, which is unsuitable for real time in applications. We opted to use, that's why we opted to use reinforcement learning, which is has an automated and adaptive real-time mitigation learning mechanism illustrated in this figure, which the reinforcement learning algorithm is trained through neural networks and takes adaptive countermeasures according to the observations that we have from the environment. Then the evaluation of the countermeasures applied is evaluated if it aligns with our predefined objectives or not through its effect on the environment. And this effect is fed into the neural network through a negative or positive reward, which would allow the agent to enhance its countermeasures through the learning process. And this would iterate till that we reach our predefined objectives. In this slide, we position our work with respect to other approaches. Where during these 3 years, we have provided a first approach where we had a simple SDN network architecture. We provided real-time mitigation countermeasures for bandwidth throttling. It was restricted to bandwidth throttling. We considered we preserved a quality of service metrics, including only delay for legitimate users. We considered as attacks TCP/SYN, UDP, and ICMP. In our second approach, we tried to expand first the network architecture that we are, the experimental environment that we are working on. We expanded the observations of the RL model, reinforcement learning model, and we expanded also the countermeasures to include besides bandwidth control, also traffic redirection. We considered also as quality of service metrics, we considered jitter and latency for legitimate users. But in these both approaches, where for the second approach, we have also an extended version, but I have presented them together. And in both approaches we were using static neural networks, which restricted us from proving the scalability of our work, and that's why in our ongoing approach, the third approach, we focus on proving the scalability of the proposed framework. We have only one article of the related work that they considered the scalability, which is the research of Atomus Plus. So we are working on this. We considering permutation invariant and equivariant neural networks, which is dynamic neural networks. We consider cost efficiency for resource and resource consumption. We expanded the range of flooding attacks to also to include the application layer attacks like HTTP GET and HTTP POST. We have also added stress flooding attack. Through extensive experiments, we present some of of the results that we got on a simulated environment using Mininet, and on our reinforcement learning model was programmed using Python. We got throughput enhanced by more than 100%, 60% reduction of latency, 40% reduction in jitter. And by the end of training, we did a comparison with all the flooding attacks that we considered. This is for the second approach, because till now we are waiting for the results for the third approach. And at the end of training, during ICMP attacks, we got like 80.4% of the legitimate traffic reaching the server, and reduction in malicious traffic in general through all other approaches, other attacks, approximately 90%. We have published for our first and second. We have an article and review, and we are now working on an article for the third approach. And for more details, you can join us in the poster session. Thank you.